the basics physics of water. First of all, I understand that you would trust me more if I was wearing a white coat and I could say, oh, I had degrees, physics degrees from McGill University. And at some point in the comments, I'm gonna read, learn science, you don't understand physics, go back to school, read the books, and yak, 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 okay? But anyone can do science, okay? Observation is the key. You can put a number and math and say I don't understand physics on anything and you don't understand the formula, but nothing is more efficient than observation and comprehension of what the fuck is going on. Okay? So about the basic physics of water, okay? You don't need to be a rocket scientist to understand that water lies flat, okay? When it's at rest, it lies flat. Water can curve? Of course water can curve, okay? It's curving right there, okay? Takes the shape of the container. If I blow on it, my earbud. If I blow on it, it curves. You can picture the big wave in the ocean. There's wind on it. It makes big wave. I saw Globers posting picture of big wave. Look, water can curve. Water can curve. Of course water can curve. That's not what we're saying when we're saying water's flat. When there's no wind, the water is going to be flat. No one can disagree with that. And another thing is the droplet of water. Okay, you can see the droplet here. It's round. Yes, because water can curve. No one disagrees with that. Okay, it falls. It's a round shape, but when it falls in the water at rest, it lies flat. Okay, another argument a glober came up with. This glober actually lives upstairs and is probably sleeping right now while I'm recording this video, and I'm gonna show it to him. Basic science. Everyone can do it at home. Okay, so he says, first of all, he shows me a picture of a droplet. Look, it curves. Yeah, it curves. But what happens when it falls in water at rest? It lies flat. But then he comes up with the argument, and he's right. I'm gonna show you. When the drop, okay, I'm gonna put more than one. Okay, when it's in the plate, you can observe. I just want to make sure we see it on camera. You can observe that it's curved on the side. Yes, he's right about that. Okay. A word that the Globers love very much is scale. Picture scale, okay? It doesn't have to be as big as the ocean, but at the end, that's what it is. But it doesn't have to be that big, okay? Of a difference of a scale. It could be that or that, okay? This is curving, but if you say that, look, it's curving here, and you compare that to the ocean, that means you assume that ocean are big bubbles like that. That's what you assume? Okay. But here, okay, if you take from point A to point B inside of this glass of water at rest, you can measure that inch of water to be perfectly flat. Okay? Water at rest lies flat. Okay? If I fill the plate with water, okay, on the side, you can see here, because I've heard, okay, it was FTFE. I don't know if you're familiar with that clown, but it tells me, oh, you can observe that it curves on the side. I was talking in a glass. Maybe you can observe that on the side it curves. But if you take measurement of, let's say, 2 inches inside from point A to point B, you can measure it to be flat, perfectly flat. Now, let's take it on a larger scale. Okay, it's harder to take measurement on the ocean because on the ocean there's always big waves, so you can't really measure the flatness of the water. But I'm pretty sure you all have been at a lake, a large lake or whatever, a lake, okay? And on a quiet morning, there's absolutely no wind, so absolutely no wave acting on the water. That would be a good time to take measurement on a bigger scale. Whatever, okay, is your measurement, okay? You can take a measurement of a meter, a mile, 100 meter, okay? Yeah, I use the two system. That's what we do here. Mile, meters, foot, whatever, okay? Whatever the unit of measurement you use. Let's say you calculate 100 meters, okay? So you measure in your lake 100 meter. You can measure it flat. It's gonna be flat, okay? If water was solid, let's say it froze and it's ice, and you put a level on it, it's gonna be flat. Okay, now don't come up with the argument, I didn't freeze right and the level could be a little crooked. Yeah, but let's say that it froze perfectly flat, like this, okay? Like water lies perfectly flat, okay? You're not gonna pick up that little curve that's here, okay? Yes, water can curve. Don't come back with water can curve. Of course water can curve. We can all observe here that there's a curve, okay? And if I blow on it, like the wave in the ocean, that's a small wave that just created here, okay? On the bigger scale in the ocean, on that quiet lake, if there's wind, it's gonna curve. But if it's at rest with no wind, you can measure it from point A to point B in the middle, and this little curve's not gonna have an influence on your measurement, so it's flat, okay? And even if I create wave, like there's wave in the ocean, if it's at rest, let's say there's, okay, for a moment, for a second, all the waves stop in the ocean, the water's gonna lie flat. That's basic science. That's basic physics. You can tell me, go back to school, read a book, you don't understand physics, and yada yada yada. Okay? Water is gonna lie flat. You're not gonna change that. Show me a picture of a droplet and tell me, look, water can't curve. What you're saying, that Earth is a droplet of water? Is that what you're saying? Because Earth is not composed of liquid, 100% liquid like a droplet of water, okay? And anyway, I understand that when you guys show me a drop of water, is because you assume that us flat earthers think that water can't curve, but we can all observe that water curves. That's not what we're saying. It lies flat, okay? It can be measured with laser beam. If I take a laser beam, it can be 100 meters, it could be 1 mile. If you try to pick up a curvature and prove that there's no curvature, you're gonna measure it like, let's say, 6 mile, like the Bedford level experiment by Samuel Robotham. So let's say in my quiet lake with absolutely no wind that morning, I take my laser beam, I put it 2 feet over the water, okay? And I put a mirror 6 miles away. I point my laser beam in the mirror. You can agree that the laser beam is gonna stay all the way at 2 feet over the water, and it's gonna hit the mirror. It's been done. You can do it. I can do it. We can all do it. Okay? No one can deny that it's gonna happen. Now, the globers say that gravity curves the laser beam. Okay? So, if gravity, the theory of gravity basically is mass attracts mass, what's the mass of a laser beam? Okay, because gravity doesn't act on helium, so are you telling me that a laser beam is heavier than helium? Because gravity attracts the mass of the laser beam and makes it follow the curvature. But speaking of follow the curvature, not only the force of gravity attracts the laser to make it follow the curvature, but precisely that, it doesn't attract it to the water or even to the bottom of the body of water like gravity would. It should do that. Okay, if gravity was real and the laser beam with its mass, which makes no sense, but if you come up and say, oh yeah, laser beam has a mass, oh yeah, laser beam has a mass, okay, let's say that I believe you and that laser beam has a mass and it's attracted by gravity. Why gravity makes it follow the curvature of the earth and doesn't attract it to the bottom? It's like the airplane. Okay, the pilots are gonna tell you themselves that they fly straight and level. It's even an aviation term. I heard it from a pilot. Straight and level. Once they reach their altitude, they fly straight and level. So the globers say, oh no, it's because gravity adjusts their altitude, but gravity doesn't pull the plane towards till it hit the ground. But that's how gravity was supposed to act if it actually was real. So that's how it would supposed to act on the laser beam too. Why would it leave it at 2 feet over the water magically? Have you thought about it? No. It's how you see it. The laser beam goes straight. You can see it. The laser beam goes straight. You know what the glober told me? He sent me a video, and the video, the title of the video say, how how bending light, it was showing how light is bending, okay? And in the video, he was showing me a guy, like the guy was like leaking water and pointing the laser in the leaking water, so you could see the laser beam follow the leaking water. But it was inside the water. The water acts like a mirror, okay? And then he was showing me another experiment in the same video, and his laser beam was going through the water, and it deflected the laser beam. I say, okay, yeah, I can see that, but my laser beam is not going through water. It's not because I make my experiment over a body of water that water is relevant. Because if I was over a flat surface, which would not be water, why would my laser beam bend? It's not supposed to bend over water either, because it's not going through water. I'm just over water because I'm sure that on a body of water it's always going to be flat and nothing is obstructing, the laser beam. It's a perfect place to make a test. But if I was 100% sure that an art surface was as flat as the body of water, I could do my laser experiment over that surface, okay? Or I can wait in the winter so the lake is frozen, and that would be over a hard flat surface. You understand what I'm saying? You can say that a laser beam is curved by gravity to follow the curvature of the earth. That doesn't happen in real life. That's not science. That's that pseudoscience to deny the reality that the water is flat. Because if you do it over the earth, over a flat surface, like, let's measure, okay, let's take a length of 100 meter and level it, okay, with a construction level, and it's flat, okay? There's not a slight curve, okay? Let's say it's not natural, it's inside the gymnasium, okay? It's perfectly flat. Your laser is gonna follow if you put your laser two feet over the floor, it's gonna follow the floor. So why gravity doesn't attract the laser beam to the floor? It leave it 2 feet over the floor? Why? Have you thought about it? So if gravity was real, it would supposed to, if I'm over a body of water, it would not supposed to leave it 2 feet over the water. It would supposed to attract it in the bottom of the body of water. What are you gonna say? I don't understand science, go back to school, hit a book and yak. No, you think about it. You can do science. I just did it now. What you have to do now is think. Water at rest is flat, and most of the Earth's surface is water, okay? A glober told me, because I told him, well, 70% of the Earth's surface is water, and he says, ha, you're using mainstream numbers. That means you think the Earth is round, or you accept science, you take the number whenever it fits your narrative. But I mean, okay, I say 70% because the mainstream science says 70%, but like, we can all agree that the surface of water of Earth is water and there's land, okay? We can all agree with that. So let's not argue about the percentage, okay? Whatever the percentage is, Okay, I was gonna say most of the surface, but yeah, I assume most of the surface of the earth is water. Okay, oh, it's because mainstream tell you that. Okay, let's say I'm wrong, and most of the surface is earth after is land, hard land after all. Okay, that's what Globers do. They deflect the conversation not to talk about the flatness of the water, the observable flatness of the water. Oh, there's a little slight curve here on the side. Yeah, take a level, measure from A to Z in the middle. It's flat. So your little curve here doesn't on scale, okay? Picture it on the bigger scale in a pool or in the ocean. Your little curve on the side, does it affect the flatness in the middle? And that flat earther that came up with the term water mountains, okay? Because if you assume that in the ocean it curves, okay, like that to form the globe, that is a water mountain right there when you think about it. And that flat earther, I don't know if he knew what he was doing when he created the term water mountain, but it's clever as fuck. Well, if he thought about it, because it made the globers, I mean, laugh about it, like water mountain, ha ha ha. And what I answer to that is water mountain, ha ha ha, fucking indeed, it's ridiculous. But that's what you believe in, because if you think that the drop of water in the bottom of the plate, that curve, you can observe that. Okay, earlier, well, let's empty that that plate. As long as we're doing science, let's do it and observe it. Okay, the drop of water, okay, in the bottom of the plate. Okay, it's more than a drop. I just want to make sure you see. Well, we all know that on the side it curves. Okay, well, if you compare that drop of water scale on a bigger scale to the ocean, that means you assume that the ocean goes like that and it forms the globe. That's what it means. So picture it on a bigger scale, because Glober loves to say that, oh, flat earthers don't understand scale. Well, if you compare a drop of water that curves on the side to the ocean, I can confirm that you don't understand scale and you don't understand physics. Oh, I have a degree in physics. Oh, you have a degree in physics? If you compare a drop of water to the whole ocean, you have poor comprehension of the simple physics of water. Because if the wind stops for a second and you have the time to be in the middle of the Pacific Ocean with no wind, water is gonna lie flat, just like in your lake with no wind. That it's possible, because in the Pacific Ocean, of course it's just theoretical. The wind can study, there's always gonna have wave in the ocean, okay? But on a lake, water behaves the same everywhere. It's not because there's wind forming wave in the ocean that you're gonna say, it's a globe, and your big bubble there, you can't reproduce that bubble there on a bigger scale. You have to understand that. Again, I wish you a happy new year, and the earth is flat.